Welcome back to Triptych Algebra. Today we're talking about multi-step linear equations. Multi-step linear equations are equations in one variable that have multiple operations going on both sides. Often, as in the case right here, you'll have different occurrences of a variable on both sides of the equation. The steps generally for solving these are right here. You will simplify both sides of the equation separately. You'll then consolidate the variable. This will be the most important, and I'll clarify that in 1 second. And third, then, we should be left with a two-step linear equation that we will then solve. In this case right here, if we're going to simplify the left-hand side of the equation, what I'm going to do is distribute this 2 through the parentheses here, giving me 6x minus 4. On the right-hand side of the equation, there's actually nothing to simplify, so I'll keep it as it is. Now we need to consolidate the variable. What I mean by this is there's a variable on both sides, or instances of the same variable on both sides. We need to consolidate it to one side of the equation. How we do that is we're going to subtract or add, in some cases, a number of x's to eliminate them from one side. Me personally, I like having my variable on the left-hand side, so I'm going to subtract 3 x's from the right-hand side of this equation. Because subtracting 3 x's will take away the 3 x's we have right there, but I have to do the same on the left-hand side of the equation. I will subtract 3 x's over here. This will leave me with 3x minus 4 equals negative 9. Now we've consolidated the variable. What we're going to do now is solve the remaining two-step equation. In this case, what I'm going to do is add 4 to both sides first. Finally, I'm going to divide by 3 to get x by itself, giving me a solution of x equals negative 5/3. Now let's look at a slightly more complicated version. The steps will be exactly the same, but what you'll be able to see in this example is the simplification of both sides, and then how towards the final steps they became the same equations as the last one. In this case right here, what I'm going to do is distribute the 4 through the parentheses on this left-hand side, and in fact, at the same time, I'm going to distribute this 3 through the parentheses on the second side of the equation. Now I've distributed through the parentheses on both sides of this equation. Now what I need to do is simplify both sides by combining like terms. On the left-hand side here, what I'm going to do is combine the like terms of the 20 and 23 to get 16y plus 43 equals, and then here is the 15 plus the 13 is 15y plus 28. To consolidate my variable, what I'm going to do is subtract 15y from both sides. Again, I'm doing this because I want to eliminate the y's from one side of my equation. I like to eliminate them from the right-hand side of the equation. What I'm left with is 16y minus 15y, giving me 1y, which I'll just write as y, plus 43 equals 28. And in this case, I just have a one-step linear equation. All I need to do is subtract 43 from both sides. And this gives me a solution of y equals 28 minus 43 is negative 15. Before we move forward, I just want to recap again, remind you what this solution means. This solution is the value that you would plug in for y here and here that will make both of these sides of the equation equal. This is the only value for y that will work. All right, the last two examples I want to do for this video are very, very important. These two questions have very similar issues, but their solutions end up being radically different. What I've done here in the first place is I've just distributed through the parentheses. Now I'm going to combine like terms. Now I'm going to consolidate the variable. Again, what I like to do is to eliminate the variable from the right-hand side of the equations. I'm going to subtract 63x from both sides. But what happens in this equation is very different than what happened before. I got rid of my x's on the right-hand side of this equation, as I was hoping, but because I have the same number of x's, specifically I have 63 x's on the left-hand side of the equation, my x's get eliminated too. In this case, I have no way of solving for x because my x has been eliminated from both sides of the equation. This can happen and will happen throughout mathematics. In this case, we have one of two answers in front of us. Either this is an equation where any value for x will work, which is pretty incredible. We call those identities. Or we have an equation called a contradiction that has no solutions. In this case right here, since this is a true statement after our variable has been eliminated, this means all real numbers are the solutions. Any value works. Let's quickly run through this one, and I'll show you how we have a similar situation but a very different answer. Again, here I am distributing through the parentheses first. Now I'll combine like terms. Now I'm going to consolidate the variable. As you see, we have the same situation we just had right over there. Because we have the same number of x's on both sides of the equation, when I go to consolidate my variable, I eliminate it from both sides. In this case, I'm left with negative 17 equals negative 19. My variable's gone. I'm not going to get one unique solution. In this case, I'm left with a false statement. What that means is there is no solution to this equation. It's called a contradiction.